Hi everyone, welcome to my YouTube channel Erudispace. I am Dr. Mohanty, and today we will discuss about the effect of irreversibilities on gas turbine cycle. So in this lecture, first we will discuss the effect of irreversibilities on gas turbine cycle, and apart from that we will also discuss the efficiency of the compressor and turbine, which are integral part of any gas turbine cycle. All of us know that the ideal cycle for gas turbine is your Brayton cycle, and the Brayton cycle both in PV and TS diagrams have already been discussed while discussing the Brayton cycle. But still, I will draw the TS diagram to compare the theoretical or ideal cycle with the actual cycle. The ideal cycle consists of 4 reversible processes. Out of 4 processes, 2 processes are isentropic processes and 2 processes are constant pressure processes. So the processes are isentropic compression, followed by constant pressure heat addition, followed by isentropic expansion, followed by constant pressure heat rejection. This actually represents the ideal cycle. But in actual case, the isentropic processes do take place with some increase in entropy, because irreversibility is the law of nature. Reversibility is purely a hypothetical concept. So what effect it has got on the performance? So the actual process will be carried out just in this way. So if you consider the actual processes, the cycle will be 1, 2, 3 and 4. 1, 2, 3, 4 represents the actual gas turbine cycle considering the effect of irreversibilities. When that is ignored, or we consider the ideal cycle, this is 1, 2 prime, 3, 4 prime. Now you can observe that due to the effect of irreversibilities, there is change in both the compression work as well as the turbine work. The compression work, WC, is H2 minus H1, whereas in ideal case it is S2 dash minus H1. So the compression work is increased due to irreversibilities. Similarly, when you consider the turbine work is H3 minus H4. Here also the turbine work is decreased. Now, what is the net effect? Compressor work is increased. Compressor is a power consuming device. It is not a power generating device. So you have to do more work in compressing the working substance. And as far as the turbine is concerned, turbine is a power developing device. So here we are getting less work output due to irreversibilities. So the net effect is that you get less work output than what you would have got under ideal condition. And the loss in work output is equal to H4 minus H4 gas plus H2 minus H2 gas. So what is happening to the heat supplied? The heat supplied is also decreased because heat supplied has become S3 minus H2, or you can say that this is the less amount of heat that you are actually supplying. Had it been an ideal process, the heat supplied would have been H3 minus H2 gas. So we do supply less amount of heat when it comes to the actual cycle. And all of us know that efficiency is the net work output divided by heat supplied. So here the net work output is decreased, so does the heat supplied. But the decrease in work output is more compared to the decrease in heat supply. So the overall effect is that the efficiency of the cycle is significantly reduced. Now, another thing that we are going to discuss is the efficiencies of the compression and the turbine. What is the efficiency of the compression and turbine? As far as the efficiency of the compressor is concerned, that is the difference between ideal enthalpy drop divided by the actual enthalpy drop. So what is ideal enthalpy drop? Ideal enthalpy drop is H2 dash minus H1, and the actual enthalpy drop is H2 minus H1. Similarly, what about the efficiency of the turbine? The efficiency of the turbine is the ratio between actual enthalpy drop divided by ideal enthalpy drop. And when we are considering the ideal enthalpy drop and actual enthalpy drop when it comes to compression, it is with reference to the compression, and when we are considering the actual enthalpy drop as well as the ideal enthalpy drop when it comes to turbine, it is related to the turbine. So there should not be any confusion related to this. So this is equal to H3 minus H4 divided by H3 minus H4 dash. Now, another important thing that you need to remember, that we have discussed so many cycles. We have discussed the Otto cycle, we have discussed the diesel cycle, we have discussed the dual combustion cycle. But while we are considering the effect of irreversibilities when it comes to gas turbine cycle, because irreversibilities is the law of nature that is also observed in other cycles. But when it comes to your Brayton cycle, it is very, very significant. And an efficiency of 60 to 70% both in case of compression and turbine may even lead to an overall efficiency of 0% when it comes to the Brayton cycle. So as far as practicable, the efficiency should be higher so that we get a reasonable efficiency when it comes to your Joule or Brayton cycle. Another thing that I would like to tell you, that this efficiency of the compression and turbine are also known as isentropic efficiencies. That means you may find the use of isentropic efficiency of the compressor instead of the term efficiency of the compression. Similarly, you may get the term isentropic efficiency of the turbine instead of efficiency of the turbine. So when both the terms are used, they do represent the same thing. That means the efficiency of the compressor as well as the isentropic efficiency of the compressor are exactly same. Similarly, the efficiency of the turbine and isentropic efficiency of the turbine are exactly same. So now I sincerely believe that this lecture on effect of irreversibilities on gas turbine cycle would be extremely useful in understanding the actual Brayton cycle, and also you have a fair idea about the efficiency of the compressor and turbine. If you have any doubt related to this lecture, please do put questions so that I will try to answer. I would request you to subscribe to my channel if you have not done so till now. Please do share this video with your friends and relatives. Thank you very much for showing your patience in watching this video. Hope to see you soon for another lecture on my YouTube channel, Erudispace.